G'day chemistry students. In this video we're going to start looking at concentration calculation. So in the last video what we were looking at was the concept of concentration, the idea that we could measure the amount of stuff put into a quantity of liquid. Today we're going to quantify that concept a little bit more and complete some calculations around it. Let's get into it. So first off, this formula you will find in your formula sheet. It's the second one here, that C is equal to N over V. Pretty straightforward. C stands for concentration, N stands for number of moles, and V stands for volume. Now on this slide, I'm just going to show you the units that we usually measure that in. So concentration is in moles per litre. N is what we already know as moles. And V is in litres. Litres there. Note that a lot of the time that we'll be doing measurements where you get given measurements that are in milliliters. If you use these values in milliliters and don't convert them to liters, you will end up getting an incorrect answer. So first off, concentration can kind of be measured in two ways. We can either talk about the amount of solute per amount of solvent, and this is not what this equation here represents, but rather it represents the amount of solute by divided by the amount of solution. Now, as we talked about last time, there are lots and lots and lots of ways to measure concentration. Some of them are solute versus solvent, others are solute versus solution. And in particular, we're going to be focusing on this concentration here called molarity, moles of solute per litre, which is C being the molarity or the concentration equal to N moles of solute over V, which is volume of the solution. There are lots and lots of others. We might explore a couple of them in class in the coming days, but for the most part, for this course, we should be focusing on this molarity concept. That is what our equation is. Anyway, I've got a couple of calculations to go through with you now to show sort of how this equation works. So let's go over there. All right, so I've got three calculations to go over with you. The first two just work with the C equals N over V equation, and the other one brings back our N equals M over M calculation to find mass. But let's get stuck in. So the first one says that I have 2.56 moles of copper to nitrate, and that they were dissolved into 300 mils of water. And the question is, what is the solution's concentration? So first off, we're being told that we have copper to nitrate. So I'm going to write down the formula just for a little bit of practice while I'm looking at it here. So I have copper with a charge of 2+. I have nitrate ions as well, and they always have a charge of -1. So to balance those out, I'm going to have to make sure that I have 2 nitrate ions for every copper ion. Now that's the formula of copper nitrate that we're going to be working with today. Now in this first one, what we've been given is the number of moles of copper nitrate, and that is 2.56. We've also been given the volume of the copper nitrate solution as well. And we know that that is 300 mils, remembering that we have to be doing all of our calculations involving concentration with litres. So I've done that conversion straight away as well. All I've done is divide the number by 1,000. So we've been given N and V, but the concentration is what we're being asked to find. So the concentration of copper nitrate, just notice as well, I need to put 2's under all of my nitrates. So the concentration of copper nitrate is currently unknown, and what we're actually trying to find today. So what we know first is that C is equal to N over V. I know N and I know V, and I'm trying to find C. So all I need to do is substitute and calculate. So let's get that done now. So C is equal to 2.56 over 0.3. And that is equal to So that's equal to 8.53 repeater. Now note that 0.3 only has one significant figure in it. Even though there are lots of zeros over here, this first number is the only significant figure. There's no decimal place indicating any further degree of accuracy. So we have to report to one significant figure in total. So that's going to be 9 moles per litre. Just note as well that you may see or use units as well that might look like this, mole over litre, or a big capital M. All of those units mean moles per litre. Let's move to the next one. So the next question says, if I have 20 mils of 1.4 molar solution of sodium chloride, how many moles of sodium chloride units are present? So for this one, what we should do first is look at the formula of the sodium chloride. Again, just for a little bit of practice. So sodium is +1 and chlorine is -1. So their charges balance out. So the formula of sodium chloride is just NaCl. What we've been given so far, or what we know, is the volume of sodium chloride, which is 20 mils. So that's 0.02 litres. We have also been given the concentration of the solution. So C of NaCl is equal to 1.4 moles per litre, or capital M we can use as well. What we're trying to find, though, is the number of moles of this solution. So the number of moles is unknown and something that we're trying to find. So what I would do first is write the equation that we're going to use and rearrange. So C equals N over V is what we know, but I'm going to rearrange that so that N is my subject. I'm going to solve for that. So N is equal to C times V. All we need to do from this point is substitute and go from there. So what we know is that the volume is 0.2 and the concentration is 1.4, or 0.02 I should say. So N is equal to 1.4 times 0.02. We can calculate that quite easily. 1.4 times 0.02. So that's 0.028, noting that, again, we can only report to one significant figure given the accuracy, the original accuracy of the volume that we were given here, that was only reported to one significant figure as well. So the answer is going to be 0.03 moles. For our final question, the beginning is going to look very similar, so I'm going to speed through the start of the question. The difference is going to be what we do with the number of moles at the end. So first off, we have calcium chloride. Calcium has a charge of 2+, and chlorine has a charge of -1. So what we can do from here is just write down our formula. So that's going to be CaCl2, because we need 2 chlorines for every 1 calcium. I'm then going to write down my concentration that we've been given. Going to write down the volume of the solution. So the volume here is what's being drawn into the pipette. So that's 50 mils. What we don't know is the number of moles, and we should be able to use that to find the mass. Later we'll also need the molar mass, but I will do that when we get up to it. So first things first, C equals N over V, but we want to find the number of moles so we can know our mass a little bit later. So N equals C times V. To do that, I'm going to substitute in 3.57 and multiply that by 0.05. So that is equal to 0.1785, but we're going to be reporting to one significant figure yet again. So that is going to be closest to 0.2 moles of calcium chloride. Now that's not what we were actually asked for. We were asked particularly for the mass. So we're going to have to convert these number of moles to mass. This is something that we've done before. The only thing that we're missing is our molar mass. So we know that N equals M over MM. But we want to find M, so we're going to, or the mass, so we're going to make that the subject, meaning that the number of moles is equal, the mass is equal to the number of moles times the molar mass. So the question remains, what is the molar mass of calcium chloride? So in this instance, the calcium has a molar mass of 40.08 grams per mole, and the chlorine has a molar mass of 35.45 grams per mole, but because there are 2 per unit, we have to multiply this number by 2. I can then calculate that. So our molar mass is 40.08 plus 35.45 times 2. That is equal to 110.98 grams per mole, which I can use to substitute into my equation. So my mass is going to be equal to 0.2 times 110.98. So that's going to be 22.196. But again, we have to report to one significant figure. So we're going to be writing that as 20 grams. And there you go, some simple calculations involving concentration. Thank you very much, everyone. In the next video, what we're going to be looking at is making standard solutions. So a demonstration of a practical. I'm going to be showing you how to use some of our equipment, some new equipment that's really high precision compared to other ways of, it's really precise at measuring volumes. Certainly unlike any other piece of equipment that you have used before in the lab, such as using a measuring cylinder. So yeah, I'll show you how to do those in the next one. Until then, have a good one.